So this video is just walking you through and kind of introducing you to some of the important things to look for in notes for macromolecules. You do not have to watch this video. Everything I say is going to be in the notes, but this is just because it's a blended day to give you a little extra help if you need it. So macro means big. Molecules, right? Many atoms together. So these are big molecules, and these are big molecules of life, living things. That's why we're studying them in biology. So I'm going to read through the why because there's often important information in here, and it kind of introduces us to some of the weird pictures that you're seeing below. So from the smallest single-celled organism to the tallest tree, all life depends on the properties and reactions of 4 classes or categories of organic, well, we think of as organic produce or whatever. The true meaning of the word organic in a science term just means it has carbon in it, carbon-based, has C. Compounds. I'm going to highlight these, and I would highlight them on your document too. Carbohydrates, lipids, proteins, and nucleic acids. These organic molecules are the building blocks of all living things and are responsible for most of the structure and functions of the body, including energy storage, insulation, so keeping you warm, growth, repair, communication, and transfer of hereditary or genetic information. Simple organic molecules can be joined together to form all the essential biological molecules needed for life. So the way these notes work, you'll have many notes that are the same type. Essentially, it's going to have a model, which is just a picture that looks very overwhelming at first. Then you're going to have several questions ask you about the model. Usually the questions are just making you observe the model in detail. First, I'm just going to observe the model in detail without reading the questions. So here are those 4 categories: carbohydrates, lipids, proteins, and nucleic acids. Notice that 3 of them have this word underneath. This word underneath refers to the monomer. Monomer is a fancy way of saying mono, one, individual unit. So these things are the individual units that make up these things. Lipids don't have one. Amino acids are the individual unit that make up proteins. And nucleotides are the individual unit that make up nucleic acids. You could think of these as Legos. So if here's like my Lego castle, and I'm sure you guys could make better Lego castles, but there's my Lego castle. If I considered this whole thing a carbohydrate, each individual Lego would be a monosaccharide or a monomer. These are the pictures of monosaccharides. You may have heard of glucose. Now, if you look, it's kind of overwhelming, but H just stands for hydrogen, O for an oxygen. Now, wherever you see a dot, that is a carbon. We don't draw the carbons all the time because we are lazy. That's really the only reason, but that means there's a carbon. So things that you might notice about the carbohydrates, their rings are like circles, lots of O's and H's. I go down to the lipids. They're a little more overwhelming, but here I can see like these just mean carbon, carbon, carbon. Weird things happening, not in a ring form. These all 3 look different or look the same, but these all kind of look different. Okay, now I go and make some observations about proteins. There's weird names here that I'm going to ignore because I don't really know what they are. Something that's interesting is there's an N here. The ones above didn't have an N. N there stands for nitrogen. I go to the nucleic acids, kind of do the same thing. Another weird N, a weird P, that's a phosphorus, which is why it's phosphate group, and some other kind of parts. I think I know what sugar is, and I'm noticing, oh, that ring looks like these things because those are sugars too. Once I'm done kind of making my observations, then I go through the questions. And you'll notice in me talking about some of those things, those were some of the questions, so it makes it easier. Like the first one asks, which elements are present? Well, the first is done for me. Carbon, that's the like hidden carbon, hydrogen, oxygen. Lipids, carbon, hydrogen, oxygen. I didn't notice anything else. Amino acids, carbon, hydrogen, oxygen, and nitrogen. Nucleic acids, carbon, hydrogen, oxygen, and nitrogen and phosphorus. How I remember the importance of carbon, hydrogen, and oxygen is Harry Potter's girlfriend in the fifth one, Cho Chang, but you don't need to remember it that way. But just know that those three elements, carbon, hydrogen, and oxygen, are clearly vital to molecules of life. So then I'd kind of keep going and see if you can answer some of the other questions. A long chain carbon backbone. Well, it's kind of hard to think about what a backbone might be, but if you look, like this one has lots of carbons in a ring. This one kind of looks like a backbone. I don't see a long chain of carbons on the other ones. So then if you kind of flip over, keep going, you'll see that it keeps giving you more questions, but also more information. So now it's saying, ooh, that fatty acid chain of lipids is referred to as a hydrocarbon chain. That's what it was talking about, the backbone in the lipids. So then you kind of keep going, and it's just making you notice some different structural things in those molecules. When you get to a read this, my students often think, oh great, I can ignore that. No, usually after a read this, there will be a question that asks you about the information in there because the information in there was really important. So make sure you do read, and I would even highlight, like during chemical reactions. The bonds, we talked about this in notes too, are continually broken and reformed. To break a bond, energy must be absorbed. When bonds are formed, energy is released. If you remember that 21 Jump Street video of the fire, that was bonds being formed, covalent bonds, in fact. That was thus the fire, or the energy is released. So keep reading, highlighting through. I'm going to walk you guys through a little bit of Model 2, and then we'll be done with the video. So again, I'm going to do the same thing as Model 1. I'm going to look at it first. Model 2 are reactions. So when we talked about reactions, we talked about how reactants, then there's an arrow, form products. Reactants are like ingredients, products are what we make at the end. So notice that there's three different ones. A, B, C. The three different ones are specific reactions, but they all do the same thing. They all have this thing plus this thing plus this thing equals a big thing plus water. A big thing plus water. This thing plus a smaller thing equals a big thing plus water. Now this image down here is showing you an overall image. So two individual things equals a big thing plus water. Okay, now this type of reaction has a special name that the notes introduce you to. Let's see if I can spell it correctly. There we go. That's why it looked weird. Dehydration synthesis. So if I'm thinking about what that means, dehydration means take water out. Remember, water is H2O. Synthesis means make something. So dehydration synthesis is a really fancy way of saying I am going to take water out and make something. In this case, make something bigger. So use these kind of helpful things to help you answer the questions. Also notice this word parts thing, because there's a lot of weird words that are happening in here, but a lot of them have these different word parts that can help you determine what the words might mean. Do not worry about memorizing all these crazy words. Do become familiar with this and then use these words to help you understand other big ones. Just a couple things about the end of the notes. You do have some extension questions. Please do answer these. Then it tells you to stop. Do stop there because we are going to go over and do the rest as a class next time.